Okay, lesson 6.1, angles of polygons. This video you only need to watch if you missed the day we did this in class. And this is kind of the discovery of what these rules are that we need to use for like the rest of the chapter. All right, nice pretty little pictures here. Polygons, what is a polygon? Basically you have many sides to a shape cannot have curved lines, it has to be a closed figure. These are all examples of polygons right up here. All right, so I make this chart. We don't actually get to the all of these. We're going to cover all of these this chapter, but I want to discuss what they are now so we kind of know where we are, because every day we kind of spend just talking about this, we maybe spend a day on this, so on and so forth. So here we go. You should have this sheet, by the way. I need to turn this something or other off. This is called a quadrilateral. A quadrilateral is any four-sided figure. And we can have no parallel lines in our figure, or we can come down this route and we have one pair of parallel, I guess I should say sides. And then on this one you have two pairs of parallel sides. Okay, if you go down this path, you're looking at something that's called a kite. And a lot of times I want to call it a diamond. I don't know, a diamond and rhombus get a little bit interchanged. We're going to technically even call that a kite. Right here we have what's called a trapezoid. And then further on down, this side is congruent to this side, which makes it, and in this case it's supposedly not, it's not the greatest picture. This is called an isosceles trapezoid. Anything with opposite sides parallel here is a type of parallelogram. Okay, and then there are two types of parallelograms. There is the rectangle. So a rectangle is a type of parallelogram. And then there is, right here, a rhombus. A rhombus is a type of parallelogram. And then if it has certain aspects that make it both a rectangle and a rhombus, and those things we will learn as this chapter continues, then we call it a square. P, Q, R, S. All right, anyway, kind of cool. We'll just kind of give you a map of where we're headed this chapter. Oh, I think I have a better screen. Ignore this one, go on to this one. Concave and convex. All right. There are nice book definitions if you'd like to look them up, but I think this is one where I'd like to show you. Concave makes me think there's a side that's always caving in. So this side, these are caving in. Something is caving in. This is convex. This is a convex polygon. This is concave. This is concave. Convex. 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 The side looks to me to be caving in. Convex, concave, and convex. All right, that's how we organize them. Truly the definition, there's actually several, but I don't think this is actually the one in the book, is if you can go from a vertex to another vertex and never go outside the figure, you're okay, and that's with every vertex possible. But if you notice, if I go from this vertex to this vertex, I'm going outside of the polygon, which makes it considered to be concave. So if I can do that anywhere on my polygon, it's no longer convex, it's concave. So vertex to vertex, that line is outside the polygon. Where over here, if I pick any vertex, whoops, that's not really where I should go, to another corner, or to another vertex, all these diagonals, I can't make one that goes outside the polygon, so that makes it convex. Did I say the wrong word earlier? I meant concave when I was talking about this side, and I mean convex when I'm talking about that side. All right. Match, and I don't have the other side, but a triangle we know has three sides. A decagon, decade, 10. Nonagon has 9 sides. Hexagon has 6. Heptagon has 7. Quadrilateral 4. Pentagon has 5. And octagon has 8. All right, and you can look that up in the book as well. A diagonal is a segment that connects any two non-consecutive vertices. A regular polygon, all angles and sides are congruent, okay? So that's kind of something we talk about quite a bit. Regular you need to keep in mind. And we're going to move on to this diagonal little worksheet you've got. Okay, so first thing I'm going to have you do is draw a picture of each polygon. So a triangle would be like this. A quadrilateral is any four-sided figure. Pentagon, I'm not a very good drawer. You don't have to be either. Look at how much time I'm actually spending drawing each one of these things. A heptagon, what did we say that has? 7 sides. 1, 2, 3, 4, 5, 6, 7. Everybody has to fit when they make a 7-sided figure. Octagon. 1, 2, 3, 4, 5, 6, 7, 8. So that's what I'm going to do there. And then I'm not going to draw one for the end guide. Okay, the number of sides. This has 3, 4, 5, 6, 7, 8, and then of course n. The number of triangles formed. Oh, I didn't draw my picture. It says show diagonals coming from one vertex. Okay, well I can't draw any diagonals out of that one, so I just say the number of triangles formed is 1. Quadrilateral, I can pick this vertex, but I can only make one diagonal. Okay? From that one vertex, that is. So I actually have 2 triangles. Here, pick any vertex. You can pick a different one than me, but I can make 1, 2 diagonals. Okay, the number of triangles formed, 1, 2, and then 3. So there's 3 triangles here. Hexagon, pick a vertex. It doesn't matter which one. Go to all the other diagonals. Okay, I've got 1, 2, 3, 4 triangles. Do you see a pattern developing? Yeah, you betcha. Okay, 5 and 6. You're going to have to do that on your worksheet, though. I'm just not going to do it right here. So I can't help but notice, and this is where I want to get to here, I have 2 less triangles than I do the number of sides. 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4, so on and so forth. So actually, down here for an n-sided figure, I'm going to write n minus 2. Okay, steps to show the sum of the angle measures. So if I have one triangle, how many degrees are in that? Oh, we all know 180. Yay! Okay, because I'm taking 1 times 180. Oops, 1 times 180. Quadrilateral, I'm going to take 2. Whoops. Oh, I didn't mean to do that. 2, oh no. Whoops. 2 times 180. Okay, I've got 360. All right, and that's actually the sum of all the interior angles. I got 180 here, 360. Pentagon, I have 3 triangles times 180. 3 times 180 is 540. Okay, I have 4 triangles in a hexagon. Each one of those is 180 degrees, so I have 4 times 180. That's 720 degrees. It's the sum of the interior angles of that polygon. It's not going to change. And by the way, I don't have anything written up here that says it has to be a regular polygon. All right. Heptagon has 7 sides, but that means there's 5 triangles, so 5 times 180. Let's see, isn't that 900 degrees? All right, an octagon is 8 sides times 180. 8 times 180, I think that's going to be 1,080. Okay, we could do that for polygon after polygon after polygon. The formula, this is where we're going with this, you're taking n minus 2, and you're taking that answer times 180. Okay? So no matter, if I had a 20-sided figure, I could say 20 minus 2 is 18, take 18 times 180, and then I will have the sum of the interior angles of that figure. Okay? Just like we know a triangle always has 180. Actually, I think there was just a couple weeks ago, somebody was asking, well, how many degrees are in a quadrilateral, a 4-sided figure? Well, it's 360. Okay? So any pentagon, you're going to have 540, etc., etc. So you don't have to memorize them, you just need to know the formula. Unless you really want to memorize them all. But then what are you going to do if I give you a 27-sided figure? Okay, enough. Here's your formula, your book stuff here. It's called the interior angle sum. La-di-da-di-da. Da-di-da-di-da. We're going to move on. Okay, talk about exterior angles here. And you should have a sheet for this too. You can take a protractor, actually measure out what's this angle right here, what's this angle right here, and then what's this angle here, and I want you to add up all of those. That could be one option. Another option is to figure out if I have a regular polygon here, which all of these in this case are going to be regular. I'm just saying it. I don't have it written up there. This would be 60 degrees. So then what does this have to be? 120. So then this would have to be 120. This would also be 120. 120 times 3 is 360 degrees. Okay, so all of the exterior angles on this particular figure add up to 360. Let's see if this changes depending on our figure. I'm going to go to the pentagon here. I wonder how many degrees for each one of those angles in a pentagon. If I go back to here, pentagon has 540 degrees. Okay, so this angle right here, 540 divided by 5, because every angle is going to be the same in this regular pentagon, then I have 108 degrees. Okay, so if this is 108, this is a straight line. Yeah, 180 minus 108 is 72 degrees. Okay, well that means this one's 72 degrees, and this one's 72 degrees, and this one is 72 degrees, and this is 72 degrees. So basically I take 72 times 1, 2, 3, 4, 5 exterior angles. Let's see, that's 35, oh my goodness, 360. Okay, I'm going to let you finish the other two. I would use that method as well. So you might have to press pause because I'm going to talk just a minute here about another cool thing. I just saw this on the internet when I was looking up these pictures. It just so happens if I take this, and I take this, and I put them all together, I thought this was pretty cool. Oh, what's the total amount of the angles there? If I take all of these and add them up, 360 degrees. Yeah, a circle has 360 degrees, right? You talk about basketball, if somebody does a 180 or, I don't know, do people do 360s in basketball? I would be dizzy. Yeah, that's kind of cool. And then I set it up here. Let's take this one here. This is crazy. Oh, wrong thing. Oh, let me get the right thing. Here we go. If I move all of these little pieces together like this, oh, this is fun watching Mrs. Talley move this stuff. Yeah, once again, all those angles total up to 360 degrees. They make a complete circle. Yeah, so what does that tell you about the sum of the exterior angles of any regular polygon here? It's our exterior angle sum theorem, and they all add up to 360. Okay. Happy winter to everyone.